Hi all, welcome to another video based on the KTU syllabus of Basics of Electrical and Electronics Engineering, and today we are going to discuss another problem from nodal analysis. And here the question is, find the currents in the various branches in the circuit shown below by nodal analysis. Okay, so this is the figure. Here the first step is to identify the number of nodes in the given circuit. Okay, so as per the diagram, the nodes here is, this is the first node and this one is the second node, and also a reference node is the, so it is keeping here. Okay, so this will be the reference node. So normally three nodes are there. Okay, three nodes are there. So nodes are nothing but it's just observe the figure and find where there is the possibility of the division of current. Okay, so here we know that if a current is flowing from here, so that current, okay, if we are supposing, if we are just I am taking it as I1, so the current will divide into two. Okay, divided, the I1 current will divide into two here. One will go through this 15 ohm and another one will go through this 10 ohm. Okay, so likewise we can identify the number of nodes. Okay, so this is the first node and this one is the second node. Okay, this is not a node. Okay, because the same current is flowing through this 20 ohm. Okay, and also this one is also not a node. Okay, because there is no branch for, there is no possibility of current division here. Okay, and in this figure we have assumed the current direction also. Okay, so the second step is to identify the current direction. Okay, so v1 v2 and reference node is taken as 0 volt here. After that we are going to assume the current direction here, so it is I1 and I2 I3, and in the second node also I3 is coming here and I4 and I5 are leaving the node. Okay, so after assuming the current direction and all, we have to just write the KCL, Kirchhoff's current law equation, for both nodes. Okay, so we know that as per KCL, the current entering the junction is equal to current leaving the junction. Okay, so here the current entering the junction is I1 and I1 will be equal to current leaving the junction is I2 and I3. So I1 will be equal to I2 plus I3. Okay, so that you can see here. That is I1 is equal to I2 plus I3, and we know that the I1 here, the current I1, we have to represent I1, I2, I3 in terms of the node voltages. So here the I1 is flowing from this 100 volt to this voltage V1. Okay, so I1 can be written as 100 minus V1 by 20. Likewise I2 can be written as V1, it is flowing from V1 to this reference node, so V1 minus V reference, that is V1 minus 0. Okay, so we can neglect that V reference, so V1 by 10 will give the value of I2, and I3 will be V1 minus V2 by 50. Okay, so we have just substitute the values of I1, I2, I3 here, and we have to just solve these equations. Okay, we have to solve these equations and we have to write in the standard form like this. Okay, so you can use any method to solve these equations. You can either use the cross multiplication or LCM method. Okay, whatever maybe we have to just obtain the equation as in the standard form. Okay, that is the something into v1 plus something into v2 is equal to a constant. Okay, so the final equation we obtain is 13v1 minus 4v2 is equal to 300. Okay, so we have just use a method, that is to simplify the circuit. We are just multiply the entire term with 60. Okay, you can use any method, no problem, whatever it is. Okay, and the final equation, the node voltage, node 1 equation is 13 v1 minus 4 v2 is equal to 300. Okay, this is the equation number 1. And for node 2, we know that I3 is equal to I4 plus I5 as per the figure in node 2, the I3 is equal to I4 plus I5, because current entering is I3 and I4 and I5 are the leaving currents. Okay, so I3 will be, the equation for I3 is V1 minus V2 by 15, and I4 we know that it is flowing from V2 to the ground, that is reference node, so V2 by 10. And here the I5, okay, the I5 is V2 minus, here the 80 volt source is connected in opposite polarity. Here you can see the 100 volt is plus minus, it is connected here, but the 80 volt source is connected in opposite polarity, minus is connecting here. Okay, so we can take the voltage value as minus 80. Okay, so if we are writing the equation for I5, it should be like this, that is V2 minus 80. Okay, V2 minus of minus 80 divided by this 10. Okay, so be careful while writing the equation, because the 80 volt source is connected in opposite polarity here. Okay, and the equations are I3 is equal to I4 plus I5, and we have just substitute the equations here, and we have just solved the equation as V1 minus 4V2 is equal to 120. Okay, here also you can use any method for solving the equations, and we have to obtain the standard equation. Okay, at last we have to obtain the standard equation as V1 minus 4V2 is equal to 120. Okay, and by solving these two equations using calculator, you can use calculator, or you can solve this manually. Okay, so we will obtain the values as, that is V1 will be 15 volt. Okay, 15 volt, and V2 will be minus 26.25 volt. Okay, V2 will be minus 26.25 volt. And for finding the current in all the branches, the current I1. Okay, the current I1 is, we know that 100 minus V1 by 20, and we know that the voltage V1 is 15, so we have just substituted and find the values of I1 and the current I2. Okay, I2 is V1 by 10, so 15 by 10, 1.5 ampere, and I3 is V1 minus V2 by 15, and we know that V2 is negative. Okay, so just substitute the same value here, so 15 minus 26.25, it is not 26, it is 25. Okay, divided by 15, we will get as 2.75 approximately, and also I4 and I5 we can find using the same equation and all. Okay, and here the negative sign means here the I4 is negative. Okay, it shows that the actual current flow is opposite to that of the current direction we have assumed. Okay, and this about the problem, we have found the current through all the resistances. Okay, and one more thing, if in the question itself, if you are asked to find the current, okay, that is the power dissipated in this 20 ohm resistor, if you are asked to find the power dissipated in this 20 ohm resistor, we have to use the equation as I1, that is current flowing through this 20 ohm is I1. Okay, so I1 square into 20. I1 we have found earlier. Okay, so use that value and find the power. Power P will be equal to I1 square into 20. Okay, and sometimes if they are asked to find the power delivered by the source, okay, power delivered by this 100 volt source, we have to use the same equation, that is P is equal to VI. We have used in the mesh analysis and all. Okay, VI. So here the voltage V is 100 volt. Okay, 100. So 100 equation is P is equal to VI, and V is equal to 100. So 100 into the current flowing from 100 is I1. Okay, so 100 into I1. I1 we have found earlier. Okay, so likewise we can find any power values like this. Okay, so I hope all of you understand the problem well. So thank you all.